Now, electric force or Coulomb's law state that the force of attraction or repulsion between two stationary point charges will be directly proportional to the product of magnitude of two charges and inversely proportional to the square of the distance between them. Suppose that there are two charges, one is Q1 and another is Q2, और डिस्टेंस इनके बीच में जो है वो है R. As we know that charges when positive, then they will repel each other. Okay, if the charges one is positive and another is negative, then they will attract each other. So Coulomb's law states that the force of attraction and repulsion between the two stationary point charges will be directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Or we can say that F will be equals to K Q1 Q2 upon R square, where K is electrostatic force constant. Value of K, it will be equals to 1 upon 4 pi epsilon 0. When we calculate it, it will come out 9 into 10 raised to power 9 Newton meter square per Coulomb square. Newton meter square per Coulomb square is the SI unit of K. हम इसको बहुत easily निकाल सकते हैं. F as F is equals to K Q1 Q2 upon R square. Then K will be F R square upon Q1 Q2. F SI unit is Newton, R as distance, meter square, Q1 and Q2 Coulomb per Coulomb square. So its SI unit will become Newton meter square per Coulomb square, and the value is 9 into 10 raised to power 9. Now if the force depending on medium, then what will happen? So our next topic is force depending on medium. बट क्योंकि यहाँ पे प्लस एंड माइनस चार्जेस होंगे तो पोलराइजेशन होगा, तो जो कंप्लीट जो फोर्स होगा वो फोर्स क्या हो जाएगा, हमारा डिक्रीज हो जाएगा. ओके, एज वी नो दैट इन फ्री स्पेस force will be F equal K Q1 Q2 upon R square, where K is 1 upon 4 pi epsilon, where this epsilon is the property of the medium which determine the electric force between two charges situated in that medium. Its value is known as absolute permittivity of the medium, as we know then epsilon. If point charge are immersed in a dielectric medium, then epsilon 0 is replaced by epsilon, a quantity characteristics of matter involved in such cases, where epsilon 0 is permittivity in free space. For example, for water, permittivity is 80 times than that of vacuum. Okay, water के लिए कितना होता है ये 80 permittivity, value of permittivity. Hence force between two charges in water will 1 upon 80 time force in vacuum, or you can say air. Now the relative permittivity is firstly it is dimensionless constant, which express absolute permittivity of medium with respect to permittivity of vacuum, and it is also known as dielectric constant, which is K. We can represent as epsilon R, that is relative permittivity, okay, and it will epsilon upon epsilon 0. Epsilon is permittivity and this is permittivity in space, in medium and in space, and this will be known as dielectric constant. So from this, epsilon can be written as epsilon 0 multiplied by epsilon R, where epsilon 0 is 8.85 into 10 raised to power minus 12 Coulomb per Newton meter square, or you can say 1 upon 4 pi. So from this, epsilon R can be written as epsilon upon epsilon 0. For free space, epsilon R will be equals to 1, and for all the medium, epsilon R will be greater than 1. Okay, so then K will become 9 into 10 raised to power 9. Then force in the medium will become F 1 minus 1 upon epsilon R, force exerted by the medium. Now there are some limitations of Coulomb force. As it is applied only for first, we can apply it on static charges when the charges are at rest. Second, for point charges, as it is only consider the center of charges. Let's suppose there is a system the center of the sphere is O, the distance from this to is R. Okay, let us suppose that we have considered a charge here and the distance between the center and this charge is r. For this condition, force will not equals to q1 upon q2 upon r square. Okay, if this charge is plus minus q, then if the charge is positive, then F will be k q1 upon q1 q2 upon r square if q is positive. Force will be greater k q1 q2 upon r square when the q is negative. When the charge is positive, as the distance will increase, और जब distance increase होगा तो force will automatically will decrease. When the charge is negative, then they will attract each other and the distance will decrease and the force will automatically will increase. Okay, so it is applied only on the point charges, and the first limitation is static charges. Now let us understand about the principle of superposition for electric forces. The principle of superposition states that when a number of charges are interacting, the total force on a given charge is the vector sum of the force exerted on it. Okay, so suppose there is a number of charges and forces will F1, F2, F3 as it is vector quantities. Okay, so the total force will be, or we can say net force will be equals to F1 vector plus F2 vector plus F3 vector and so on. Or we can also write K Q1 Q0 upon R10 square R10 cap plus K Q2 Q0 upon R20 square R20